Welcome to this explainer. Now, I want you to imagine, for just a second, the ultimate heist. Picture this. You're standing right in front of a heavily fortified, massive steel vault. You don't have explosives, you definitely don't have the luxury of time. What you need to pull this off is a crew. A highly specialized team of cognitive specialists, each executing their role with absolute pinpoint precision. But the vault we're cracking today, it isn't a bank. It is the Cambridge Computer Science Examination. And whether you are tackling the IGCSE syllabuses like 0417, 0478, 0983, 0984, 2210, or you're stepping up to the major leagues with the AS and A-level 9618, the vault is guarded by the exact same impenetrable security system, the Cambridge examiners. Today, we are decoding a fascinating, foolproof strategy to completely bypass this security and secure maximum marks. Our primary target for this heist? The incredibly complex, heavily weighted concept of the interrupt service routine, or the ISR.
15. Hook that number into your brain right now. Why? Because mastering interrupt service routine handling doesn't just earn you a little pat on the back from your teacher, it accounts for approximately 15% of the total marks in Paper 2 across all those critical syllabuses we just mentioned. 15%. To put that into perspective, that is not just a passing grade. That 15% is literally the entire difference between a C and an A or an A and an A star. It's massive. If you walk into that exam room without a highly specialized tactical plan for handling ISR questions, you are basically leaving the vault door locked, turning around, and walking away completely empty-handed. But by digging into the actual mechanics together today, we're going to discover exactly what the examiners are desperately looking for on your paper.
You know, it's actually fascinating how easily this heist falls apart for most students. Let's look at a couple of classic profiles. First, take a typical crammer. We'll call him Alex. When faced with a complex ISR question, absolute panic sets in for Alex. And the result? A massive raw data dump. Hardware interrupts, software interrupts, division by zero errors, the printer being out of paper, it all just gets vomited onto the page in a giant, unreadable paragraph. But there is zero actual analysis. And guess what? The examiner's red pen just strikes right through it. No marks. Now contrast that with our other student, Sam. Sam is a rusher. The question on the exam clearly uses the command word evaluate, right? But Sam just briefly defines what an ISR is and quickly moves on to the next page, completely ignoring the command word requirements. Both of these approaches instantly trip the alarm. They fundamentally ignore the true rules of the Cambridge exam, leaving precious marks behind.
Okay, let's dive into this battle plan. Here's the structured examiner's playbook we will use to master ISR concepts today. 1. Core principles. 2. The methodology. 3. The transformation. 4. Our interactive workshop. And finally 5. Examiner warnings. Let's get to work.
Section 1. Core principles. Decoding the assessment objectives.
So what does this all mean for you? It means superficial buzzwords won't cut it anymore. Examiners demand analytical depth. When it comes to interrupt service routines, candidates must demonstrate a connected, highly conceptual understanding that is totally transferable to completely unfamiliar contexts. You can't just memorize what an ISR does in a vacuum. You literally have to know what it does when, say, an automated factory sensor suddenly spikes in temperature and triggers an alarm. Assessment objectives for ISR handling target 3 distinct cognitive domains: knowledge and understanding, application, and analysis. The academic benchmarks here require logical, structured reasoning. Think of it like a giant puzzle. If you only operate in the knowledge slice, just defining what an interrupt is, you are leaving 2/3 of the marks on the table. You absolutely must apply that knowledge to the specific scenario provided in the prompt, and you must analyze why the ISR functions the way it does under those exact conditions.
So how do we guarantee we hit all those cognitive domains every single time? We use a cognitive lockpick. It's called the PEAL framework: point, evidence, explanation, and link. This is an incredibly structured strategy to directly answer command words without wasting a single drop of ink. First, you make your point about the interrupt. Then, you provide evidence pulled directly from the exam scenario. Next, you provide a clear explanation of the technical mechanism happening in the background. And finally, you link it all back to the original command word. It is an incredibly elegant way to ensure absolutely nothing is missed. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 2. The methodology. The method mark strategy.
Now, what's really interesting about this slide is understanding how examiners actually grade. They award points for the procedural process, not just the final outcome. Let's map out the exact standardized sequence of systematic processing required to secure every possible method mark in an ISR calculation or data interpretation question. Step 1, identify key elements. You need to deconstruct the question and extract only the relevant data. Step 2, apply relevant principles. Select your analytical framework, like the Peel method we just talked about. Step 3, execute analysis with clear working. This is huge. Do not hide your math or your logic in your head. Put it on the page with perfectly clear notation. Step 4, verify results. Check your boundary conditions. Step 5, present it all in the appropriate format using correct, syllabus-approved terminology. By strictly following these 5 steps, you are literally being graded on your analytical footprints. You're showing the examiner exactly how you crack the safe.
Section 3. The transformation. Rewriting the code live. The crucial point here is mastering the deconstruct, solve, evaluate problem-solving method. When faced with a massive 6-mark ISR question, a top-tier student doesn't just grab their pen and start frantically writing. No way. First, they identify the given information and break the problem down into manageable, logical steps. That's the deconstruction phase. Next, they solve systematically, ensuring every single step naturally flows to the next. Finally, and it's actually fascinating why this is the hardest step for most students, they evaluate. They check for reasonableness and make justified recommendations. Higher-order assessment objectives demand that you evaluate alternatives and compare different approaches. You aren't just solving a math problem, you are justifying to the examiner why your solution is the absolute most optimal way to handle that specific hardware interrupt in that specific system.
Actually, think about the device you might be watching this explainer on right now. Every single time you tap the screen, pause a media player, or receive a text notification, you are triggering an interrupt. Mastering these concepts isn't just about passing an exam, it's about understanding the invisible heartbeat of the technology we use every single day. The exact same logic keeping a massive global server farm running is managing the low battery alerts on your smartphone. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, Interactive Workshop, Data Scans, and Finding Flaws.
Okay, it is time to get hands-on. Data interpretation is absolutely critical for this heist. When you are scanning a complex data matrix like the one you see here, you need to extract meaning from binary representations almost instantly. Look closely at the table. Notice how the flag register's bit 4 shifts from a 0 to a 1. What exactly does that signify in the context of the system? In a real testing environment, you have roughly 60 seconds to process this visual information, extract that binary change, perform any required hexadecimal conversions or calculations, and begin to formulate a solid, evidence-based conclusion. The data always tells a story. The real skill, the skill that gets the A*, is translating that raw binary story into a perfectly structured analytical paragraph, smoothly and accurately.
Let's pivot to our next challenge. Can you find the flaw in this sample paragraph? Take a moment and really process this text as I read it. When an interrupt occurs, the CPU stops what it is doing and handles the problem. This is important because hardware can fail. Software interrupts also happen. The system then goes back to normal. Think about our flawed students from earlier, Alex and Sam. Based on what we know about examiner commentary and the Peel framework, what is the massive structural failure happening right here?
The brutal truth? The entire paragraph relies on superficial, generic breadth. It says absolutely nothing specific. It's completely hollow. Now contrast that with a top-tier critical analysis, which requires comparative connectives. It requires identifying both similarities and differences. A truly deep, vault-cracking answer might read like this. While a software interrupt is generated synchronously by the currently running program, a hardware interrupt occurs asynchronously, demanding immediate suspension of the fetch-execute cycle. Consequently, the CPU must push the contents of the program counter to the stack to preserve the system state. Wow. The difference is striking, isn't it? It uses context-specific analytical depth. It uses concrete technical evidence. It leaves absolutely no room for doubt in the examiner's mind.
And this brilliantly illustrates exactly why timed practice is so vital. Imagine a 30-second speedwriting challenge right now, where you have to mentally formulate one perfect Peel paragraph. Imagine the exam question is, evaluate the use of an ISR when a printer buffer is empty. Go. Think about your point. What is the immediate action the system takes? Think about your evidence. We're looking at the buffer status flag, right? What is the explanation? The processor has to pause its current task to send a new batch of data to the buffer. And finally, link it back to the overall efficiency of the printer operation and the CPU's time. Structuring your thoughts like this under a tight time constraint makes real-world exam problem-solving feel completely natural.
Section 5. The final system and examiner warnings, securing the vault.
We have done the legwork, we've studied the blueprints, and here is the ultimate system. If you follow these 3 rules consistently, every single piece of the puzzle clicks into place. Rule 1. Command word decoding. You absolutely must tailor your answer to whether the question says state, describe, explain, or evaluate. Never ever give a basic state answer to a complex evaluate question. Rule 2. Peel framework application. Structure every single long-form answer with point, evidence, explanation, and link. Rule 3. The time management matrix. Allocate your time strictly based on the mark scheme. If a question is worth 6 marks, you need 6 distinct, valid, context-linked points. Don't write a novel for a 2-mark question, and don't write a single sentence for a 6-mark question.
Now, I need you to listen very closely to this direct warning from the principal examiner reports. This is straight from the people holding the keys to the vault. Quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario." End quote. This is the golden rule, guys. If the scenario is about an automated greenhouse temperature sensor, and you write a beautiful paragraph about ISRs, but do not explicitly mention the greenhouse, the rising temperature, and the specific sensor, your generic answer will immediately fall flat. 0 marks. Context is not optional. Context is literally the key to the vault.
To permanently encode this in your memory before you take your exam, let's count down the top 3 most frequent student mistakes chronologically. Warning 1, confusing cause and effect. It is such a common trap to mix up what actually triggers the interrupt, like the user pressing a key, with what the ISR actually does in response behind the scenes. Warning 2, forgetting boundary conditions and edge cases. When you're analyzing data or evaluating a scenario, it's so easy to forget to mention what happens at the absolute limits. What happens when a buffer is exactly full or completely 100% empty? Examiners look for those edge cases. Warning 3, as we just heavily discussed, lacking specific context. These 3 errors alone account for immense point loss globally every single year. Don't be the student who triggers these alarms.
The blueprint is complete. The heist is planned. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.